TechPlot Chorus, CFD Simulation Analytics. Simulation analytics is really bringing together three well-established concepts: business analytics, visualization and physics visualization, and data management. In this example, we're going to show how you can model the metadata or derived quantities from a series of CFD solutions to predict performance of a system. We're going to start by looking at a pretty sophisticated example. In this case, we have about 191 solutions, and we have pitching moment, drag, and lift coefficient. These are our derived quantities. We really want to understand how the system performs. So we'll quickly evaluate the derived quantities by looking at the lift curve. We'll do the same thing by evaluating perhaps the drag curve and our drag surface. And the final one, we'll go ahead and look at the pitching moment as well. Now, to get a better understanding how the system is actually performing, we're going to need to evaluate some kind of a surrogate model, and or we can use a simple response surface. So in this case, we'll pick our independent variables, which were Mach, alpha, and beta, and we'll use just a simple response surface. So we'll turn one on perhaps for each of our three domains. Now you can quickly then understand by looking at the data, okay, well, this is how this system performs. We can in fact look at the system performance by evaluating just the alpha curves. So by looking at each one, what it's showing me is the response surface based on the data being presented. Remember, this is multidimensional. Similarly, if we actually look at the beta sweep, we can then see how the response surface is changing, and you can see it changes depending on the beta that we isolate. Because remember, this is multidimensional data. Looking at a surface is important. Certainly that gives us a quick overview, but we may want to quantify these data, and we may want to reduce the error by getting rid of, in this case, we have a series of runs that did not converge. So we're going to get rid of ones with high iteration numbers. Now we'll go ahead and extend this to an XY line plot. We're going to quantify the data by looking at the lift curve. So we'll look at drag over lift, CD, CL, a curve here. And we'll go ahead and sort these by Mach number and sort by alpha, group by Mach number, and we can then show the derived quantities. So you can see that each one of these black lines represents a fit to the different Mach curves. So you can see here that if I look at just the alpha curves, the Mach curves are persistent. And if we want to then look at the individual Mach numbers, we can do that as well. And now we can walk through each Mach number and look at the resulting curve. Now for any of these and or any of the surfaces, if we choose to, we can then export the data tables derived and use them in further calculations. So in this case, we'll go ahead and extract these data into a CSV file, which we can then use for more analysis. So going back to, this is quite an interesting way to look at the data, and we can save this as a framework for analysis of metadata. For more information on this or any other TechPlot product, please visit us at our website, www.techplot.com.